Hey, good morning, everyone. Welcome to the Zoom session, the instructor session here for week two. I hope you're having a great. I hope you had a great weekend. Hope you're having a great beginning of the week. Let's go ahead and dive on in here. I don't think this one will take us too long. You'll see here that we're talking about integers and algebraic expressions in this week's material. This is a lot of stuff that you're pretty familiar with already. Just kind of living life, dealing with stuff like your bank account, writing checks, doing addition, subtraction, pluses and minuses in your bank account or maybe your paycheck, things of that nature, dealing with temperature where you have negatives. So we're dealing with what we say integers. We're talking about positive values and negative values. And more specifically, integers are values that are no decimals, no fractions. So that's probably a welcome thing from last week's material. But uh, essentially what we're doing is we're dealing with the rules for signed numbers, positive and negatives. So that's what's on tap for this week. I think you're going to find a lot of a refresher thing. Good news is that a lot of this stuff you can also do with your calculator. And by the way, on that note, if I didn't make it clear last week, feel free to use your calculator. It is perfectly acceptable to use a calculator in our class. You're going to be using it in the real world. I use it all the time to be candid with you because I make a lot of calculation mistakes. So feel free to do that. There's no bonus points for doing this all in your head. You want to make sure that you have the right answer. So feel free to use your calculator. Okay. So essentially, this is sort of a rundown of what this covers, what this week covers, dealing with integers and signed values. And basically, we're just going to go through the rules, the underlying rules for the whole thing. Now, again, you can utilize your calculator as well to help you out with this stuff. And I encourage you to at least check your answer with it. Okay, so let's start off with the notion of what is an integer and what is the absolute value. Excuse me. So integers basically are just any number that's not a fraction and not a decimal. Okay, so those numbers would be 1, 2, 3, 4, 5, 6, 0, and then also -1, -2, -3, -4, and so on. So basically, not a decimal, not a fraction. Everything else is an integer, both positive and negative values. So you'll see here when we typically talk about negative values, you'll see here what we have, what's called a number line. That's what this is right here. It's a number line. And when you draw the number line, 0 is always at the middle. It's the middle point dividing the positives from the negatives. That's essentially what we're doing. Okay, so when you think of negative, or when you think of positive too, think of positive and negative as sort of additional information. Usually what it means is direction, or a lot of times what it means is direction. But at its core, the sign of a value is trying to convey some information to you. So for example, liquid nitrogen freezes at 346 degrees below zero. Okay, that's to tell you that it's very cold. And we would represent this by saying negative 346 degrees below zero. Or we say that the Dead Sea is 1,300 feet below sea level. Sea level tends to be the starting point, the 0 point, if you will. Everything above it is rising in elevation like mountains, and everything below it is below sea level, which is kind of maybe in the ocean, or maybe it's dipped down below and lower than that. So here, the Dead Sea, if you it's in Israel, by the way, but it's basically at the sea level. If you were to extend the line out to the Mediterranean Sea, the Dead Sea would be sitting down here, 1,300 feet below that level. That's what's to indicate. And so we would signify that with a negative downward. And then Jenna's 10-year-old daughter weighs 14 pounds more than the average, meaning the average is right here. Jenna's daughter weighs above that. So the point is that positives and negatives tend to indicate direction, movement. Uh, uh, the Dead Sea is below. Okay, Jenna's daughter's weight is above. When we mean direction, we're meaning direction from the 0 point, whatever starting point that is. Excuse me. So one of the things you'll want to do and that you'll do this week is find these values on the number line. And so just a kind of a quick review of that, and probably something you already know, but just to kind of keep in mind that when we talk about the number line, 0 is always in the middle, okay? Always in the middle. And you put your positive values on the right, so, and you just tick them off, 1, 2, 3, 4. And then the negative's the same thing, -1, you know, pardon my spacing, but my handwriting's a little terrible. Let me do this, 1, 2. So here's -2, here's -3. I'll write a little smaller, and then so on down the list. So net 0 in the middle, positives to the right, negatives to the left. And so if we want to find the value of -4, well, here it is. You put a dot right here. Now, what does this -4 mean? It means, excuse me, 4 spaces uh, to the left of 0. The negative here indicates direction away from 0. So if you're moving in the negative direction, you're moving left. Okay, so -4 means left 4 spaces. If you're going to 2 here, that's +2. That means you're moving right 2 spaces. Okay, so you put a dot right here. So again, just sort of keep in mind that the theme here is that positive and negatives mean direction. Typically, when we talk about positive, we're either moving in the right direction or we're moving up. So moving right 2 spaces, positive direction going forward, or if you're moving upwards, like climbing a mountain, that would be the positive direction. And then vice versa. If you're moving in the negative direction, negative would be left of 0, and then or down below. That's the negative directions typically. Excuse me. All right. And so another thing we want to do is then be able to compare numbers where, which one's larger, which one's smaller, things of that nature. And there's 2 ways to sort of go about doing it. And I tend to prefer the number line way of doing things. What you can do, so let's take a look at our number line here. And I'm going to just draw some ticks here. So 0 is always in the middle. Okay. So 1, 2, 3, 4, 5, 6, 7. Here's 1. Here's 3, here's 5, and here's 7. And then let's do -1, -2, -3, -4, -5, -6, -7. Okay, here's -7, here's -5. Okay. So what you want to do is identify, -7 and -4. Which one is bigger? Which one is smaller? And the way that you delineate that and determine that is the further left you are on the number line, the less you are. The further left, the more less you are. So if we were to take our numbers here of -4 and -7, so here's -4 right here, that's -4. And this value, this dot right here is -7, okay? -7 is further to the left of -4. So that means that -7 is less than -4. That's how you determine. Whichever one is on the left is the lesser number. So here, 0 and -4, how about those? Well, here's -4 again. We got that right there. And then 0 is right here. So -4 is to the left of 0. So that means that 0 is greater than -4. Okay, so we would use the greater than symbol here. And then 2 and -7, well, every positive is always greater than every negative. And we can see that here. Here's the value of 2. Here's the value of -7. And we see that 2 is further to the right, meaning that it's greater than. So that's the test. That's how you determine which one is which. And typically the hard ones are, I think these are the more tricky ones when you have 2 negatives, because we tend to think of 7 as bigger than 4, but when you put negatives in front, the more negative you are, the less you are. Like one of the other things you have to do is talk about the absolute value. And the absolute value really is associated with the number line, but really all it is that it's the distance between the number and 0. The distance between a number and 0. So what do we mean by that? The distance between number and 0. Well, let's go back to our number line here. Okay. So if I wanted to put something here, say, what is the absolute value of 3? Okay. So what we're asking ourselves is, well, here's a dot for 3 right there. Okay. What's this distance between 0 and 3? So ask yourself how many spaces you move. So start at 0. 0 is always your starting point, by the way. I forgot to mention that. So 1, 2, 3. I move 3 units to get from 0 to 3. Okay. So the absolute value then of 3 is 3. That's the distance, 3 units. Okay. Well, what about if I had something like, the absolute value uh, of -3? Okay. So here's -3 right here. Here's -3. So we're asking ourselves, what's the distance between 0 and -3? We'll do the same thing. How many units do you move? So you're starting here at 0, okay, and you move to 3. So 1, 2, 3. Okay. Even though we're moving in the left direction, the number of units we move is also equal to 3. So the thing to take note of here is that when we talk about the absolute value, it's asking us what's the distance between that value and 0. So because of that, because we're talking about distance, the absolute value is always going to yield a positive number because we're talking about distance. Because think about it in your head. Does it make sense to talk about distance in a negative fashion? No. How far away is it from here to New York City? -1,600 miles. That doesn't really jive in our head. We always talk about distances and positive values. So that's sort of just trying to reinforce that idea is that when we're talking about absolute value, it always returns a positive value because it's measuring distance. And that's why no matter if you got a positive value inside or you got a negative value inside, what it returns on the outside is always going to be negative, always going to be positive. Okay, so let me take some of this down because it's nice to have our number line drawn. So let me take this down right there. Oops, no, right there. So let me clear it. Okay. And so when we do these values, then, when we do these answers here, determine the absolute value of -5, asking us the distance between 0 and 5. So we have to move 5 units. Yeah, to the left, but we have to move 5 units to get from 0 to -5. So the absolute value is 5. Uh, so what's the absolute value here? What's the absolute value of 0? Well, how many units, how far away is 0 from 0? 0. 0. It's already there. It's already there. Okay. So we can okay, so we'll move forward then and kind of then go to the notion of the opposite. And when we talk about the opposite, we actually truly are talking about opposite signs, okay? Opposite signs, changing the sign of. So think of positive negatives as opposites of one another. +2, which you see here, one dot is on +2, the other dot is on -2. So they are opposites of each other because they're the same value, but different opposite signs. That's what we mean by opposite. And we generally denote that by the opposite of a number is generally, you put that negative in front. So I can say the opposite, let me do it this way. What is the opposite of 4? Okay. And the answer would be -4 because this value here is +4. So we do the opposite, which is -4. But what about if I do, what's the opposite of -7? Well, I would do -7. I'd take the opposite of -7. But those two negatives, oops. Sorry. Let's do those two negatives. If I had the opposite of -7, those two negatives would cancel each other out to give a positive. Okay, we'll talk about that in a second too. But anyways, just basically turn it from positive to negative or negative to positive, whatever you got. Take the opposite sign of your value. So we have find the opposite of things like -108. So then the opposite of that would be the value +108, okay? And the opposite of +54 would be -54. Just change the sign. So now what we move into then is the rules for working with positives and negatives, adding positive and negatives, subtracting positive and negatives, multiplying and dividing. And probably the more challenging part is the addition and subtraction of it all. And really, the way that we add positive and negative, let me actually, I don't really like the number line version, so let me jump ahead in the PowerPoint here. Um, let me do it this way. This is the way I like it. To add two numbers with the same sign, you add their absolute values and apply the common sign. That's the rule. So if I'm going to add, 5 plus 3, well, we know that one. We know that's 8. But what this rule says here is add the absolute value of 5 and add the absolute value of 3. So that's 5 and 3 to get 8 and attach the common sign. And here the common sign would be positive. Positive 5 plus positive 8 gives us positive 8. And we can just write that as a plain old 8. So stuff that we already know, just trying to put it into this format of using positive and negative. But suppose we had something like -7 plus -4. Now notice I put the -4 here in parentheses. That's sort of to keep it separate from that plus sign there. Now what we would do with this, the way that this process applies, if you were to do this by hand, is take the absolute value of -7 and the absolute value of 4. So the absolute value, remember, returns positives. So the absolute value of 7 is 7. The absolute value of -4 is a positive 4. So we add the 7 and the 4 together to get 11. And then it says, then apply the common sign. So I should probably say attach the common sign. Okay, so they're both negative here. And so we would attach the common sign to get a -11. So essentially the way it works is when you're adding two values of the same sign, add them like you normally would and just attach the common sign. So the addition of two positives will give you a positive. So if you want a kind of a rule, a positive plus a positive will yield a positive, and then a negative plus a negative will also yield a negative, okay? You add the values together and then attach the common sign. That's all you do. And so we can see some more examples like this. -2 plus 4, you add the 2 and the 4 together and attach the common sign. So 2 and the 4 will give the 6, and we attach the common sign of negative. -5 plus -3, combine the 5 and the 8 to 5 and the 3 to get 8, attach the common sign. That's how that works. Now, when we're dealing with negatives, when we're dealing with negatives and positives, to add two numbers of different signs, the way that you do it is you subtract the values and you attach the sign of the value of the higher value. What do I mean? So let's take this one right here. Right here. Okay, 2 plus -7. You subtract the values, 7 minus 2, and that gives us a 5. And you look and you attach the sign of the quote unquote larger value. In other words, which one has a larger absolute value? So here, this one is positive. This is a positive 2, and this one's a -7, okay? So which one has a larger absolute value? Which one is the bigger number? Well, it's this one right here. So we're going to use the negative as the final sign. That's the sign that's going to prevail in the final answer. How about here? -6 plus 24. Well, they're different signs. We have a -6 and a positive 24. So we subtract the values to get a value of 18. And because 24 here is positive, then we use the positive sign as the sign of the final answer. One quick note. The sign in front of a number is treated as the sign attached to it. So the 24 in this case has a plus sign only, meaning that the 24 is going to be treated as a positive number, And here, this example right here, -8 plus +8, that one's telling us that when you add opposites, they cancel each other out to give 0. And by the way, oh, I don't have it. You can always check this stuff with your calculator on your phone too. So feel free to, do that as well. But the rule here is when you're adding values of different signs, subtract them like you normally would, and then take this and then attach the sign of the larger value. Larger value meaning the one with the highest absolute value, that's the sign you use. Okay, let me jump ahead. Let me go to the other rules. Subtraction. Subtraction and addition are actually pretty much the same thing. What you do here, let's take a look at this. 15 minus negative, 15 minus 20. You can do that on your calculator, easy peasy. But suppose you didn't have your calculator, so how would you apply that? Well, essentially what you do is this sign here gets attached to the 20, okay? Gets attached to the 20. And you insert a plus sign in between. So this becomes 15 plus negative 20. So the minus sign becomes attached to the 20, the number to the right of it, and you treat this as addition. So the reason we do that is because remember we just reviewed a rule of how to add two values of different signs. And so you apply your rule here. Oh, we'll subtract the values and then attach the sign of the larger absolute value. So we get -5. We can even do it here when we have -7 minus -12. We would take the minus sign here and attach it to the 12 as a negative, okay? And insert a plus sign. So this becomes -7 plus -12. And so then we can then do the addition because it's the addition of numbers with the same sign. Remember that rule, you combine the values, add them as you normally would, and then attach the common sign. And again, by the way, you could pipe this into your calculator and you'd get the exact same thing, okay? So these rules are more of a refresher. If you didn't have your calculator, how would you do it? Now take a look here. We have a minus sign in front of a minus sign. So this right here is going to be treated as the opposite. So it's basically going to turn this thing here into a plus sign. So when you have two minus signs next to each other, they cancel to give a plus. Oops. So this becomes then 40 plus 8. And then we get 48 as the answer. Sorry, my phone is just going bananas. Okay, I don't know why. Apologies. Okay, so that's the lesson here. The difference between this problem and the other ones is that when you have subtraction here, you take the sign here in the middle, and attach it to the value on the right, and insert the plus sign in between. So effectively, what you're doing is you're converting subtraction into addition. Okay, and again, you can check these on your calculator too. Okay. The other thing, the next rule is multiplication and division. And we can do these at the same time because there's one rule that applies to both multiplication and division. And the rule is this. Well, I'll just type it right here. Let's see. Maybe they have it. Well, I'm looking ahead and I see that they don't have it. So I'm going to type the rule right here for you. Okay. When you multiply or divide values of the same sign, the result is positive. That's the rule. Okay. When you multiply or divide values of the same sign, the result is positive. Whereas if you multiply or divide values of different signs, the result is negative. So it doesn't matter if you multiply the values or divide the values. If they're the same sign, positive, different signs, negative. Applies to both operations. And so let's see some examples of that. So we're multiplying, well, let me do it one at a time. So we're multiplying here. Let me do this one. So this reads -2 times -6. When you have a number right on the outside of a parentheses, -2 times -6. So what you do is you multiply the 2 and the 6 like you normally would to get 12. And then because it's negative times negative, the result becomes a positive 12. And so then we just write that as a plain old 12. The positive is implied. +3 times -10. So we multiply the values as we normally would to get 30, but because they are different signs, we attach the negative. -14 times +3. So we multiply the 13, I'm sorry, the 14 and the 3 as we normally would, and that gives us, I think, 42. And they're different signs, so we get negative. And again, take the opportunity to check these on your calculator. Positive 4 times positive 8, same sign as positive, so we get a positive 32. And then how about this one here? Negative 5 times 0. Take a guess. What do you think? Well, you multiply 0 times anything, you always get 0. Doesn't matter if it's positive or negative, always get 0. So then what we can then move into in the slide that you saw me jump to after that is, suppose we have 3 numbers, 4 numbers. How do we do the multiplication of several numbers all at once? Well, calculator if you want. But remember, you multiply 2 values at a time. So you basically you do the multiplication from left to right. Okay, so start with the first 2 numbers. Here, negative 2 times negative 5. So that becomes 5 times 2 is 10, and negative times negative is positive. And then just take the 7, negative 7, and bring it over. So it becomes 10 times negative 7. Now do that multiplication, 10 times negative 7, and that gives us negative 70. So you have to break it into multiplying 2 numbers at a time. Similarly here, just move left to right in doing the multiplication. So we do negative 4 times 2 first, and that gives us negative 8. And then just bring over the negative 1 and the positive 5. Then we do negative 8 times negative 1 gives us a positive 8, and then bring down the positive 5. Oops, sorry. Positive 5. And then finish with the 8 times 5, and that gives us 40. And there it is. That's the answer for this one. B. So just a reminder, what this problem shows us is that when you're multiplying values, even if you have a lot of values, you only multiply 2 at a time, and you move left to right in doing your multiplication. It's similar as well for division. Well, I'll come back to this in a second because that's exponents. Well, I'll do exponents now. I'm sorry. I'll do exponents now because we're doing it. Exponents is basically just simplified multiplication. So let's put these on hold for a moment, okay? Let's just talk about what an exponent is. So we read this as 2 to the 3rd power. The big number 2 is what we call the base, and 3, the little number at top, is called the exponent. And all it does, it's just simplified multiplication, shorthand multiplication. What it does is it says, take this base of 2 and multiply it with itself 3 times. Or another way to sort of think of that is to say, I want 3 copies of the 2. I want 3 copies of the 2. Okay, 2, 2, 2, and you multiply them. That's what that means. This is how many 2's you're going to multiply together. So we have exponent of the 3, we're going to multiply 3 2's. And so we get, so do 2 times 2 times 2, and we get 8. If I do 5 times 4, that means I want 4 copies of the 5. I want 5 times 5 times 5 times 5. And if I were to do the multiplication altogether, I would get 625. Make sure you check my work. But that's what the exponent means, is how many copies of the base are you multiplying with each other. Okay, so with that in mind then, let's turn over how do we handle when there's negatives involved with this, okay? So let's take a look at the first one, negative 4 to the 2nd power. Now take note here, we can kind of compare and contrast the first 2. What's the difference between them? In the first one, the negative is trapped inside of the parentheses with the 4. In the second one, there is no parentheses. So what does this mean? In this first one here for A, because there's a set of parentheses and the exponent is on the outside of those parentheses, it means that this exponent of 2 is raising the 2nd power of everything inside. So you want 2 copies of that negative 4. You want 2 copies of that negative 4, so it becomes negative 4 times negative 4, okay? And that gives us positive 16. But what about this one here? Because there's no parentheses around that negative, the 2 is only being applied to the 4. The 2 is only being applied. So when we talk about copies, it's only 2 copies of the 4. What happens to this negative? You just attach it. It's just sitting there hanging in front. So just put it in front. So we are multiplying 4 with itself 2 times, but we're just attaching that negative sign is floating in front. And so you just attach it in front. And then that gives us a negative 16 as the result. What about negative 5 to the third power? Well, this says 3 copies of the negative 5. Everything is in the parentheses, so it's negative 5. Pardon my handwriting, I'm sorry. I could type it, but I think it's a little loud. So negative 5 times negative 5 times negative 5. Feel free to check me on the calculator, but it's going to be negative 125. Why negative? Because this is positive 25, and then times negative 5 becomes a positive times negative is negative. Okay. What about here? Well, we're multiplying 5 with itself 3 times and just attaching that negative. So it becomes 5 times 5 times 5, and then attach that negative. So this is negative 25 times positive 5 is also negative 125. So the moral of the story here, if you want to kind of take a step back and what are we really trying to show you here? One, we're trying to help you to appreciate the mechanics of working with exponents. The exponent only, tells you how many copies you have, but when you see parentheses or you don't see parentheses, you have to ask yourself, what is being raised to that exponent, okay? The significance and the difference, if you notice here, when we took 4, the negative 4 with and without the parentheses, yielded responses that were different signs. But when we took the negative 5, when we took the 5 and raised it to the third power, you get the same response. What in the world is going on here? Why the difference? It's the exponent. It's the exponent. Sorry, I thought someone was at my door. So here's the, if you want a bigger lesson out of the whole thing, the real effect of the parentheses here only matters when your exponent is even, 2, 4, 6, 8, 10, whatever it is. Typically, you only deal with 2. That's where you're probably going to get, that's where you would get a different sign, and that's where you're going to see it in Alex. Notice here when the exponent is odd, the sign is not going to, you'll get the right sign, no matter how you do it, with or without the parentheses. That's the moral of the story. But if you just kind of stay with the approach of asking yourself, what is being raised to the exponent, you kind of tend to put you on the right track, on the right path. Okay, and then finally, we're here with division. Remember I told you the rule, if you multiply numbers of the same sign, positive, multiplied numbers of the different sign, negative. It's the same rule with division. Divide values of the same sign, positive, divide values of different sign, negative. So when we do something like this one right here, 50 divided by negative 5, they are different signs. So the result is negative. And then you just divide the 50 and the 5 like you normally would, and we get negative 10. Look at this right here. Notice that reads as a fraction, 42 over negative 7. When you see a fraction bar, and here it's going to be this rule going forward, and it was even the same rule last week in week 1's material. When you see a fraction, that is the division operation. You can treat it as division. So here, the fraction negative 42 over 7 can be translated to and read as negative 42 divided by 7. And so you could do that on your calculator. If you typed it in, negative 42 divided by negative 7, it would get a 6. 42 over 7 is 6, and the positives cancel to give us a positive. The negatives cancel to give us a positive. Similarly here, the fraction negative 39 over 3 translates and reads as negative 39 divided by 3. So divide the 39 and the 3 as you normally would, it's 13. And because it's negative and then positive in the bottom, then it's negative as the result. How about when we have 0? How about when we have 0? This one here, by the way, is the same thing as 0 over -7. So I'll write it as a fraction too. So here's the delineation. 0 in the numerator means that the entire fraction reduces to 0. Try it out. Do it on your calculator to see. 0 in the denominator, try it out on your calculator. See what you get. You get a big old error. Okay. What does that mean? It means that the answer is what we say is undefined. You can't have it. The 0 you can't have in the denominator. You can't divide by 0 in the denominator. So 0 in the numerator reduces the entire fraction, the division, down to 0. 0 in the denominator, it's undefined. And you would say undefined, undefined. Okay, so I see I'm at the end of the PowerPoint here. So essentially this week's material is all about getting comfortable with positives and negatives, working with the absolute value, as well as doing the addition, subtraction, multiplication, division using positives and negatives. So, try these rules out, doing it by hand, get comfortable with it, but always give yourself a quick self-check with your calculator too. Again, there's no bonus points for doing it all in your head. And I want you to use your calculator to give yourself a quick self-check so that you get the right answer, because you're working at Alex, you know this by now, that if you get it wrong, you have to redo the entire problem, and that just adds more time. So I use my calculator all the time, and I'll be candid with you. Sign errors are my number one mistake. I've been doing this decades, coming on 4 decades now. Uh, and sign errors are still my number one mistake. I always check with the calculator, so I hope you are too. Anyways, so I laid on pretty thick, and I'll stop. Hope you found this helpful. Let me know if you have any questions as we go along. Happy to help out, and look forward to seeing everyone in the discussion board. Hope you have a great day. Bye-bye.